Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Tilted by Sotir. And here are the rules. We have Chaos Construction Sudoku, where we need to construct 9 contiguous and orthogonal regions such that every row, column, and region, every row, column, and 9-cell region contains the digits 1 through 9 once each. So this is a valid 5 orthogonally connected region, or a contiguous orthogonally connected region, because you can go from any cell in that region to any other cell in that region, staying within the region just by going through edges. This would not be valid because to go from this cell to any other cell in the region, you either have to go outside the region or you have to cross a corner instead of an edge. Likewise, this is not an orthogonally connected region because these two cells, even though they can connect to each other by going through edges and staying within the region, they cannot connect to any other cell in the region by staying in the region and connecting just through edges. So that's an example of how chaos construction rules and regions are made. We have sum/product lines, and lines are bisected by only one region border. So every line is only bisected by only one region border, such that no digit repeats on the line, so there are no repeats on the line, and the products of digits on one side of the border equal the sum of digits on the other side. The value of the sum/product, if given, is the number in the top left corner of a line's top leftmost cell. So this line is bifurcated or bisected essentially into two regions by one region border. And on one side, you have a product that multiplies to 32. And on the other side, you have a sum that adds to 32. So that should give you some information there. Same with this. This line must have a product that on one side of the border that multiplies to 18, and on the other side, it adds to 18. And that's the same with any line that has a digit in the leftmost cell of the top row of that line. We have black crop key dots, where cells separated by a black dot have our values in a ratio of 1 to 2. So for example, if this were, say, a 4, this would have to be a 2 or an 8 to maintain the 1 to 2 ratio between them. And we have white crop key dots, where cells separated by a white dot have a value of values with a difference of 1. So, for example, if this were, say, a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. So again, remember for the sum/product lines, the value of the sum on one side is equal to the value of the product on the other side, even if there's not a number given. The number given, though, does give us more information about the way that that divides. And there are no repeats on the line. So those are all very important things to keep in mind. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so for the 32 line, we know it's the digits 1 through 9. That means on one side, it must sum to 32, and on the other side, it must multiply to 32. The only way to multiply to 32 is if you have... The only way to add to 32, you have to have 3 digits or 2 digits on the other side. I guess you could have 4 technically. But the problem, okay, so the problem with 4 is that to multiply to 32, you need specifically the digits 4 and 8 at least. Right? 2 and 4 by themselves would leave another 4 possible, but the problem is you can't get 4 in any other way to multiply in the same row. So it has to be 4 and 8, and that adds up to 12. So the remaining digits add up to 33. Well, you subtract out 1, that gives you 32, and 1 times 4 times 8 multiplies to 32 also. So on one side is 1, 4, and 8. On the other side is the rest of the digits. So the border has to be either here or here. And these digits cannot be 1, 4, and 8 because 1, 4, 8 is either on this side or it's on this side. So this must be 2, 3, 5, 6, 7, or 9. But these digits are in a 1 to 2 ratio with another digit. So these cannot be 5, 7, or 9 here. Therefore, we know one of these is 3 or 6, right? It is a 3, 6 pair. So that means this cannot be 3 or 6. So 3 or 6 has to be with one of the 3 or 6 here. The other one has to be 1 or 4 to be in a 1 to 2 ratio with a 2. So 2 cannot be here. So this must be 3 or 6, 3 or 6, and this is 1 or 4 here and 1 or 4 here. Okay. So this can never be a 3, 6 pair here. This must be 1, 2, 4, or 8 here. And it can't be 2 because one of these has to be 2 to be in a 1 to 2 ratio with 1 or 4. So this is 1, 4, or 8 no matter what, because it can't be 5 or 7, 5, 7, or 9, because 5, 7, or 9 halved, which it means it's the 2 part of the 1 to 2 ratio, would be 2.5, 3.5, 4.5, which are not digits. And if you double 5, 7, or 9, you get 10, 14, or 18, which are not digits. That's the reason why you can't have 5, 7, and 9 there. So this must be 1, 4, 8 because one of these is a 3, 6 pair. The other one is 2 with 1 or 4. Well, since this can't be 5, 7, or 9, it has to be 1, 4, 8, which means this is the 1, 4, 8 section. And this must be a boundary here. So this is a boundary. This is then not 3 or 6. So this is 1, 4, 8, 1, 4, 8. This 1, 4, 8 triplet means this has to be a 2 here to be in a 1 to 2 ratio with the 1 and 4. This then must be 3 and 6. And these are 5, 7, and 9. And this is all the same region. So we're going to mark that light and this as dark. Let's draw a boundary around the rest of the grid. We have, this is 1, 4, 2, 8. So this is also 1, 2, 4, or 8 here. This must multiply to 27. The only way you get to multiply to 27 is 3 and 9. So it's either 2 digits or it's 3 digits. You can have a 1 multiplying with it. 27. So say you had 27 and 3 and 9. $27 as a sum, and 3 and 9 adds up to 39 already. So that means this adds up to, at most, 45 minus 39, which is 6. So this is guaranteed to not have an 8. This becomes a 1, 4, 1, 4 pair, which eliminates 1 and 4 in the rest of the row. So this must be an 8. This 1 and 4 is in a 1 to 2 ratio with only 2. So that's 2. You can't have 1, 3, and 9 here. If this is 1, 3, and 9 multiplied together, that's 13. And if you add with 27, that's 40. which would force this to add up to 5. But 2 and 1 and 2 and 4 only add up to 3 and 6. So this must be 27 and 3 and 9. So the border is either here or the border is here. We're not sure which. Either way, the sum of 27 plus 3 and 9, which is 12, must be 39. So this must be 2 and 4, which makes this 1. Okay. So the border, so we know these are all the same region. We just don't know if it's part of this region or if it's part of this region. So either this is, okay, so this cannot, okay, this cannot be 1, 2, or 4, 1, 2, 2, 4, or 4, 8 as a pair. This must be a 3, 6 pair. And we know 3 and 9 have to be on one side of the border. And this can't be 3, 9 then, because of the 3, 6 pair in this area. So this must be 3 and that's 6. Therefore, this is all the same region, and this is a separate region. But this could be the same as this region, even. This is 3 and 9. This is a region border. The rest of these digits are 1, 5, 7, 8. 3, 7 adds up to, sorry, 5, 7, 8 adds up to 20, and 1 and 6 add up to 7. So that does add up to 27 there. Okay, so we have that. One of these is 30, the other one is, the other section is, adds up to 30. So we need a guaranteed 5. And we're missing one digit. Excuse me. One digit on this line. Because we have 8 digits on the line. So 5 has to be on one side to multiply to 30. You need a 5, and you need a 6, a 2 or 3, or a 1. I'm not sure if that's helpful. This orange cannot be the same region as this dark, because we already have an 8 here and a 1, and this must contain 1 and 8 here. So this has to be a separate region. So this is correct then. This is going to be orange, and this is blue. This dark has to get out. And it cannot be part of the orange region, so it must be part of this line. So we know these are both dark, because we know we have a 5 or 6 at least guaranteed. And it could be 4 digits. And in fact, actually, I think it has to be, this has to be the 5, 6 part, or the 5, 2, 3 part. Right? This is orange or dark. We don't know which. Yeah. Say it wasn't the 5 or 6. How do you add up to 30 without 1, 8, and 4? Adding up to 30, so that would also require a 5. But we know, right, it would have to be 3, 3, 5, 7, 6, 3, 5, 6, 7, 9, adding up to 30 without a 1, 8, or 4. But the problem is you require 5, and the 5 has to be in the product side of the sum product line, because there's no other way to get anything that is a multiple of 5 without a 5. So this must be the 5 part. This cannot be the sum. So we know 5 has to be one of these. It cannot be 2 and 5. Sorry, it cannot be 2, 3, and 5. It has to be 5 and 6. And it cannot have a 1. So this must be then 5 and 6 here specifically. And the rest of it is adds up to 30. Okay. Without 5 and 6, what digits can you add up to 30? You must have a 2. I think that's guaranteed. And because this is long, it's not going to be the same as the light region. So this must be essentially all a different region. We're going to make that medium. Because this is 5 digits. These 6 digits have to be in the same region. Because, again, every sum product line is bisected by one region border. This couldn't have a 1 again because the 1 is already in the dark region, and this must be part of the dark region. And it can't have a 2 because it can't get outside of the 2. So you have 2, 3, and 6. So this must 2, 3, and 5. So this must be a 5, 6 pair. To add up to 30 without a 5 or 6, because there are no repeats on any line. It has to contain a 2. It's either missing a 4 or it's missing a 1 and 3, right? Because 5 and 6 add up to 11. The rest of the digits must add up to 30. We're missing 4 total in value, and it's 1 digit. So we're missing a 4, actually. Therefore, this must be a 2. This is a 2. This light has to go somewhere, so it must go here. So this is a separate region, which means this is medium also. We're missing a 4 here. So this must, okay, so these are the regions here. This has to go down this way because there's no other place for it. So this is light. This actually has to be a 1, 4, 8 triplet because there's no other possibility here. This is 2. This can't be. There can't be 4 in any of these digits because they add up to 30 without a 5 and 6. So this must be a 4 here, which means 4 cannot be here. This has to be what? A 1, 3, 7, 8, 9. And that with a 2 should add up to 30. 1, 9, 3, 7, and 2, 8 does add up to 30. This must be 4, 5, or 6. We don't know here which is the product and which is the sum. Okay, remaining digits in column 1 have to be 2, 3, 6, 5, 6, 7, 9. The only digits that are in a 1 to 2 ratio of those is 3 and 6. So this can't be 3 because of the 3 in the row, so that's 6 and 3. This can't be 3 or 6 here. That's 3 in the corner. We celebrate because we're getting closer to solving it. Still not quite there, though. If this is 2 and 5, this doesn't... Okay, so if this is 2, this is 4, 5, or 6 because the remaining digits here are 1, 3, 7, 8, and 9 to add up to 30 on this line. Again, this box region borders divide lines into only specifically 2 sets of segments. So this is the same medium gray as this region. This dark has to go somewhere. And it must go somewhere on one of these lines. We're not sure which. Anyways, this is 4, 5, or 6. If this is 2 and 4, that adds up to 8. Or sorry, that adds up to 6, which this cannot multiply to. If it's 2 and 4 multiplied together, that's 8, which this cannot add to, so this can't be 4. If this is 2 and 5, it adds to 7, which this can't multiply to. If it's 2 and 5 multiplied into 10, 4 and 1 and 8 can never add up to that. So this has to be 2 and 6. 2 and 6 add up to 8, but this doesn't multiply to 8. So it must be 2 and 6 multiplying to 12, and 4 and 8 adding up to 12. So this is 8, this is 1. Okay, so this cannot be 8, and this cannot be 1. We have 24 here. 5, 7, and 9. Of those, none of them can multiply to 24. So this must be the added part. One of these is 2 also. So we are guaranteed at minimum 2, 5, and 7. 2, 5, and 7 add up to 2, 5, and 7 at minimum adds up to 14. So 2, 5, 7, 14 plus 6 plus 3. Okay, to multiply to 24. You can't have 2 digits. If it's 2 digits here, it would have to be either 3, 8 or 4, 6. And if it's 2, and this is 3 here, and the 6 already is on the line. So this can't be 4, 6. 3, 8 can't be here because of the 3 in the row. So it must be the first 3 digits. So this must be a border. So the first 3 digits multiply to 24, and these digits must add to 24, and it includes a 2. So 2, 6 is 8. 24 minus 8 is 16. So this must be a 7, 9 pair. So it's 2, 7, 9. Therefore, we can't have a 2 remaining in the product of this line. It has to be 1 and 8, I believe. It can't be 4 and 2, which multiplies to 24. Yeah, so it has to be 1 and 8. So this is one region. It cannot be the gray region. We're going to make it a green region, and this must be a separate region. So this is red. Okay. 15. To multiply to 15, you need 3 and 5. 3 can't be any of these digits. It could be 3, 5, or 3, 5, and 1. So the multiplication part has to be one of these. So 3 has to be one of these, and 5 has to be one of these. So this is a 2, 7, 9 triplet, which eliminates 2, 7, 9 in the rest of the column. So this is 5, which means 5 cannot be here. 5 can't be here. 3 and 5 have to be here, guaranteed. It could be a 3, 5 pair here, but we don't know. So this cannot be 3. We have either 4 digits or 3 digits adding up to 15. If it's 1, 3, and 5, how do you add up to 15? Well, if it's just 3 and 5, can 4 digits ever add up to 15? 1, 2, 3, 9 doesn't work because you have a 3. 1, 2, 4, 8 does work. 1, 2, 4, 7 also works. Sorry, no. 1, 2, 4, 8 works. 1, 2, 5, 7 would have to be the case, and that's not allowed. What about 1 with any other digit? No, it would have to be. So if it's 4 digits, it has to specifically be 1, 2, 4, 7. Okay. If it's 3 digits with 1, 3, and 5, it would not have a... Well, okay, 6 can never be on this line. So you can't have a 6 at all. If you have 3 digits multiplying, 1, 3, 5, then you have 3 digits summing to 15. It could be 2, 4, 9. Can it not have a 2? Can it, sorry, yeah, can it not have a 2 on the line? And I think the answer to that is no. So if you just have 3, 5 by itself, it's 1, 4, 7. Sorry, 1, 2, 4, 7 adding up to 15. If it's 1, 3, 5 multiplied together, then 3 digits could be 2, 4, 9. You can't have 4, 5, and 6. So the minimum without a 2, you obviously don't have 1, 3, and 5, would be 4, 6, and 7, which does not add, which adds up to already 17, which is greater than what 15 can be. So that's not possible. So 2 has to be here. So either this is 3, 5, in which case this is 1, 2, 4, and 7. Or this is 1, 3, 5. And this could be 2, 4, and 9. Or 2, 6, and 7. And it cannot be 6 and 7. So it can't be 2, 6, 7. It's 1, 7 still could be here. This could be 2, 4, 9. So 4 has to be one of these 4 digits. Well, we know 4 actually has to be one of these 2 digits here, so this can't be 4, because there's no other place for 4 in column 2. 4 can't be here. 4 can't be any of these. This cannot be part of this gray cell, gray region. Because if it were, this already has a 3. And this is guaranteed to be 3 here for this segment. Also, this green region can never be part of this region here because this guarantees to have a 2. So it must be part of this region. So this is green guaranteed, which means this is a border here. It must have 3 and 5, and it could have all 3 of them. We don't know. So this is a separate region. It could be the red region, it could be another completely different region. We're not sure which. So 4 has to be one of these 2 digits here. 5 is one of these 3. 3 is one of these 3. 1 has to be along it, but it doesn't have to be any of these digits here. So, remaining digits in row 3. 1, 3, 4, 5, 6, 7, 9. Okay, this can't be 1. 8 cannot be along this line at all. It couldn't be probably anyways, but okay. This is a 1 to 2 pair. It cannot contain 1, 2, or 8. And so it can't be 5, 7, or 9. So this is either 3 or 6 with 3 or 6 here, or 4 with 2 or 8 here. We're not sure which. To multiply to 18, you either have 2, 9, or 3, 6. No, not 3, 6. 3... Oh yeah, 3, 6. 2, 9, or 3, 6. What does that mean? I'm not really sure. This is in a 1 to 2 ratio. It's either 4, 8 or 3, 6 here. The rest of row 9 has to be 2, 4, 5, 6, 7. That's interesting. This can't be 2 because of the 2 in the column. Okay. This 6 eliminates 6 here, so this can't be 3. So this is 4 or 6 here. Hmm. Interesting. 9 has to be... Okay, this is definitely divided in 2. How do you divide this in 2 such that you have a product on one side and a sum on the other side that add up to each other without a 2 or an 8? Well, a single digit is the product of another digit. So you could have essentially the sum on one side, 1, 3, and then 4 on the other side. And that's a product by itself, 4. I don't think you can ever multiply together. Yeah. If you have 1 multiplied with another digit, it'll be the same digit. Okay, so this could still be pretty broad here. Um, huh. 18. So we have a 4 and a 5 remaining in the medium gray cells. It could just be here. That's possible. These digits have to be 2, 3, 4, 5, 7, 8, 9. That's still pretty broad. Okay, so let's not do that one yet then. 18. Say this was the multiplication part. And this was this it cannot be 4 obviously, so this would have to be 3 and 6. Okay, that would force this to be 3. That would make this 5, that would be 6. So these 3 digits would have to add up to 18 without a 3, a 6, or an 8. Is that possible? 279 potentially could work. Yeah, that seems fine. Hmm. Hmm. Oh, the dark has to go in this region. Guaranteed. Can it ever multiply to 18? Yes, if it's 2 and 9. But the problem is it can't multiply 2 and 9 without getting this part. And then it would have to be 3 digits. And that would all be 1, 2, and 9, but we already have a 1 in the dark region. So that doesn't work. So this must be the one that adds to 18. And I think it has to be 2, 7, and 9. Right? 3, 7, and 9 adds up to 19, so that doesn't work. 2, 3, and 9 add up to 14. That doesn't work. It has to be 2, 7, and 9. And 2 can never be here, so this must go down this way. And this must add up. It's 2, 7, and 9. Because the dark has to be one of these two cells. Therefore, it's either the product or the sum. Well, with the product, it would be 2 and 9, but it can't have a 1, and it would need to have a 1 to guarantee that these 3 are the multiplication with a 2. Therefore, it must be the sum. This is 2, 7, 9, and these two cannot be. Well, without 2, 7, and 9, it has to be 3 and 6 multiplied together, so this has to be then 3 and 6. That's 3. This 3 is not part of this gray region. It has to be part of another region. So this is going to be a pink region. This is 2, 7, and 9 as a dark. This can't be dark, then this must be orange. Orange has to go out here somewhere. So it must be, it doesn't have to be this one. It could be either of these two. We don't know which. Either way, this is a separate region. This is a separate region. This is a separate region. 3 and 6 multiplied to 18. 2, 7, and 9. This can't be 2. That means this can't be 3 or 6. So this can't be 2 here. This 6 eliminates 6 here, so this is 5, which makes that 6. This can't be a 3, 6 pair. It's a 4, 8 pair, which eliminates 4 and 8 in the rest of the column. This can't be 4. This can't be 3 or 8. This can't be 5 or 6. This can't be 2. We already did 2. No 6 or 7. So this is 4 or 5 here. The rest of column 8 has to be 1, 3, 4, and 5. Interesting. This can't be 3. If this gray went to here, it would only be a single cell. And it would have to be 3. So I don't think it could go there. It goes either here or here, and it needs a 3. So it has to be that one. It can't go here. It can't go here because that would be 3, and then these 3 would have to multiply to 3 with 3 digits, which is impossible. 3 unique digits. Or add up to 3 with 3 unique digits, and that's impossible. So this cannot go this way. It can't go here because it needs a 3, so this must be dark gray, and is the last part of this dark region. These digits can never add up to the sum of 3 digits, and it cannot be the multiplication of 3 unique digits. So these both have to be orange. Because it can't be a single digit with 3 other digits here. It must be at least 2 digits here, or it could be 3 digits here. Either way, since they're both orange, they cannot have 1 and 5. This becomes a 3, 4 pair, which eliminates 3 and 4 in the rest of the column. This can't be 4, so this is 5, this is 1. This cannot be orange here. This is a 3, 4 pair. It could add up to 7, multiply to 12. We don't know. This 5 eliminates 5 in the rest of the row. This 1 eliminates 1 in the rest of the row. So 1 has to be one of these 3 digits, which eliminates 1 in the rest of the column. This can't be 1. This is 8, which makes this 1. This 8 eliminates 8 here, and this can't be 1 because of the 1 in the column, which we are guaranteed, right? It's either 1, 3, 5 times together and 2, 4, 9 here, or it's 3, 5 with 1, 2, 4, and 7. So 7 can never be here because that would require this to be 1, 2, 4, 7 here. 1 has to be one of these, so this can't be 1, which means 7 cannot. 7. We have a 7, 9 pair in column 2, which eliminates 7, 9 in the rest of the column. So this can't be 7 or 9. This is guaranteed as a 4. So this can't be 4. We have a 1, 3, 5 triplet here. This is either 2 and 9 or 2 and 7. We're not sure which. 1 eliminates 1 here. Rest of column 7 has to be 2, 4, 7, 8, 9. Okay. This can't be 2. It can't be 4 because one of these is guaranteed to be 2. This is guaranteed. This is a 4. Interesting. We need access to a 9 here. If this is part of the same region, for the orange region, if this is part of the same region, 3, 4, and 9 can never add up to a single digit, and 3, 4, and 9 can't multiply to a single digit, so this cannot be orange. Therefore, we know this is a boundary, and this must be the last orange because it can't be here, because that's a 1. So this is orange, and it must be a 9. So this is 9, which eliminates 9 in the rest of the column. This is done as a region. The blue has to get out, but we don't know which way it has to go out. Remaining digits in column 6 are 1, 5, 6, 7, 9. This can't be 1 or 6. This can't be 6. This can't be 6. Where is the 6 in column 6? This is eliminated because of the 1-2 pair ratio. This is eliminated by 6 in the row, 6 in the row, 6 in the row, 6 in the row. So this must be a 6 here. This can't be 1 either. So this must be a 6 here, which means none of these can be 6. Okay. Remaining digits in row 8 are 2. This can't be 2. No, 1, 2, 3, 4. So it's 5, 7, 8, and 9 here. Six and 7 doesn't work because they multiply to 42, which 2 digits can never add up to, and they add to 13, which 2 digits can never multiply to. 6 and 4 could work if this is 2 and 5. They add up to 10. 6 and 4 multiplied to 24, which is not allowed. 6 and so this could be 6, 4, and this as long as this is 5, 2. It could be 6, 2 added together if this is specifically 8 and 1, or it's 6, 2 multiplied together as 12, and that works with 5, 7, 3, or 4. So that's pretty broad. Okay. But these two have to be the same region. It could be the blue region, actually. Okay. These two are in the same region. So 7, if these add up together, this must be 1 and 7. Okay, that's possible. If they multiply together, that's 12. And I don't think that works. To add up to 12, it's either 3, 9, 4, 8, or 5, 7. 5, 7 works. And either way, this is 7 then, right? So if this is 3, 4, adding up to 3, 4, this multiplies to 7. And this must be 1 and 7. If this is multiplying to 12, 3 and 4 times to get multiplied together is 12, then these must add up to 12. And the only possible, there's no 3, 9 possible. There's no 4, 8 possible because of the 4, 8 pair here. It has to be 5, 7. And this would be 5, and that would be 7. So either way, this is 7. So this cannot be 7 here or here or here. This 7 eliminates 7 here, so this is 8, which means this can't be 8. So this is 1 or 5 here. The 5 adds up with the 7. The 1 multiplies with the 7 here. This can't be 7 or 8. This can't be 7 or 8. We have a 2, 4 pair in row 9, which eliminates 2 and 4 in the rest of the row. So this can't be 4. This is 7. These can't be 7 then. So again, if this is 6 and 4 added together, this is 2 and 5 multiplied together. If it's 6 and 2 added together, it can no longer be 1 and 8 multiplied together. So it has to be 6 and 2 multiplied. Can it be 3 digits ever, really? No. Because 3 digits would add up to greater than 9, and they would multiply to much greater than 9. So we know this is a boundary here. 6 and 2 multiplied together gives you... So 6 and 4 would make this 2 and 5. 6 and 2 multiplied together is 12, would mean this is either 5 and 7. So right now it's 2 and 5 as possibilities. Or this multiplies to 12, and this must add up to 12. So it'd be 9 and 3, or 7 and 5 here. Okay. This 9 eliminates 9 here. Okay. Four has to be on this line somewhere. So this is the sum of two digits, must have a 4. So it could be 1, 4 adding up to 5. Or 4 and 5 adding up to 9. 7 can never be here. So 1, 4 adding up to 5. Or 4, 5 adding up to 9. I'm guessing 4, 5, and 9 is probably the one that's going to be, but we don't really know. Let's see. Hmm. Huh. 7 has to be one of these two digits here. That's not very helpful. Okay, what are the remaining digits in row 4? We have 2, 4, 5, 7, 8, 9. 2 can be next to 1 or 3. 4 can be next to 3 or 5. 5 can be next to 4 or 6. This is basically 1 through 9 without a... Oh, this can't be 1 because of the 1 in the column. So this is 3 through 9 then. That's not too helpful. Oh, this digit, whatever it has to be, must go to here as a region, right? Hmm. Okay. We know these are the same digit. That's not very helpful. One of these must be an 8. There's no other place for the 8 in that row. One of these 3 is an 8. This 7 eliminates 7 in the column. So this can't be 7 here. Hmm. Okay. So say this was 1, 2, 4, and 7. This would have to be a completely other region because it can't be green and it can't be the same as the red. So this would be yellow. This red would have to go this way. This would be 1 then. This would be a 2, 7 pair. So this would be 7, 2. There's no 7 here. Okay. So far, this seems fine. Yellow is likely here. Blue has to get out. So this is blue. Red also has to get out. So blue would have to go this way. This would have to be red. Okay. That would force, and so this would be all done as a region. This could not be 5, this would be 9. So this would be 5. This doesn't add up to 12 anymore, so it can't be 2 and 6. This must be 4 and 6. This is 2. This 1 eliminates 1 here, so it's 5. This 2 eliminates 2 here, so it's 9. Okay, so far this is fine. This can't be part of yellow. It can't be part of blue. That's interesting. Right? Because if it's blue, there would have be a double 5 here. So this would be 3, 4, and 8. The yellow, this can't be part of yellow, can't be part of blue, can't be part of green. It would have to be part of pink. 1, 2, 3, 4, 5, 6, 7, 8. Because it can't be part of blue, can't be part of yellow. Because the yellow has 2, the blue has 5. Can't be part of green because it's too far to get there. Can't be part of red because this region border blocks that. This is 2, which makes this 4, which makes this 8, which makes that 4. Yeah, this would have to be pink because that's the only region left, right? We have 1, 2, 3, 4, 5, 6, 7, 8 regions. So 1, 2, 3, without the pink, 1, 2, 3, 4, 5, 6, 7, 8 regions. So this would have to be pink, but then the blue would not form a valid region because it doesn't have access to a 2. So this cannot be the same region. This cannot be a 1, 2, 4, 7 region. It has to be 2, 4, 9. So this is the boundary here. This then is green. This must be a boundary here because this is a different region. This must be 2, 7, and 9 adding, sorry, 2, 4, and 9 adding up to 15. Because again, it can't be 2, 6, 7 here. And you can't have 1, 3, and 5, which otherwise limits everything. So we have 4, 2, and 9. This can no longer be 3 because 3 would have to add with the 9 to add up to 12, so this multiplies to 12. I think from what we learned, if this is a separate region, it still has a problem, right? So again, if this is a separate region, the red has to go this way, the blue has to exit out, so it has to go this way. Um, and this doesn't have access to a 9 in that case, because this must be 2, 4, 9 to add up to 15. So this must be the red region. So this is the red region. We don't have any other information here. This green region needs access to an 8 and a 4. Okay. And it could be go extend to here. If it goes to here, it would extend to here, right? Hmm. This blue needs access to an 8. Can it ever not have this 8? And I think the answer is no. Right? If it tries to avoid it, the problem is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it avoided that way, but the problem is this would have to be a region by itself, and this 8 would be in a region with another 8, so that's not possible. So this is blue guaranteed, which means this has to be blue also. So this 8 has this blue region has a 1 and an 8 guaranteed. We need access to a 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe. But then this would not be a full region. Right, the red could go 3 here. Can this be a separate region? I guess is another question, right? So say this 5 was a separate region. Oh, this can't be red. If this were red, it would have to be a 2 or 4, but we already have a 2 or 4 in the red region. So this must go out either this way or this way. So this is either blue or it's a separate region, let's say yellow. So say we try to make this a separate region. So say we made that a separate region. This is a different region. This has to go out and it would block the blue. So this cannot be a separate region from blue. It has to be blue. So this is all blue. This is blue. That forces both of these to be blue. So we have 8 cells here, which are all different. This is a different region, obviously. This could be blue or red. Any of these could be blue, and it would have to have a 7. So this could be some sort of yellow region. It could be red. Red cannot go over here because that would force it to be here. And this would have to then be part of that. So it's 1, 2, 3, 4, 5, 6, 7, 8, and we wouldn't have access to a 6. Actually, this red needs access to a 6, so this can never be red. This can never be red. The access to a 6 has to be here. So we have 1, 2, 3, 4, 5, 6, 7, 8. I guess it could access here too. So one of those 6s. And the yellow has to have access to a 6 also. So any of these could be blue. This could be red or yellow. It cannot be blue because we have 8 digits already in the blue region. Also, this is a border. This could be yellow. Can it be red? No, it needs access to a 6. And this would be 5, 7, and then that would be 1 with it. So this is yellow or pink. Pink could go here too, actually. This could technically be pink. This could be pink. Okay. This red needs access to a 6. It could be here, could be here, or here, or here. Okay, it cannot be here. If it goes to here, this would be blocked off here, right? 1, 2, 3. This would form a 7-cell region, which is not possible. The green needs access to a 4 and an 8. That's fine. These are just the sum of each other, right? So it's 4 with 1 adding up to 5, or 4 with 5 adding up to 9. Same with this, right? I mean, it could be a multiplication too here, but we just don't know. This has to be an addition, though, because there's no other possibility combination of digits that would multiply together to give another digit, right? You need either 1 and something multiplied together to get another digit, which means these two are different digits, or you need 2 times something, 2 times 3 or 4 to get another digit, and this can't have a 2. So, okay. Blue has access to 2 and 4. It needs access to a 7. These are all possible 7s. So those are fine. Um, um, hmm. Hmm. Okay, this is kind of convoluted still. So green can go 2, 2, 2. So those are all the green aspects. Where can pink get to? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So any of these could be pink. It could even reach here. Pink can get it to any of these. Red has to go to here, or to here. Yellow could expand to any of these, right? These all could be yellow technically. Gray can go 2. Medium gray specifically. So it could go any of these 3, any of those 2. It could go here, I guess, too. No, it cannot go here. If it goes this way, this doesn't have a way to exit out. And this would, I mean, this could be pink, but then this wouldn't exit out anywhere. So this cannot be medium gray. This could be medium gray here, though, 1, 2. That's possible as a 4, 5 pair. Okay. That's pretty broad. Remaining digits in row 7. 1, 2, 3, 4, 5, 8, and 9. This can't be 1 because of the 1 in the column. That's it. We know there's a guaranteed 4 on this line. Okay, what happens? So what are the possibilities? This is 2 and 5. That makes this 7. Uh, that's 4. This is 2. This is 4, which makes that 8 and 4. Which would make this 3 and 4 here. Okay, that would be 9. So far, this is all looking fine. Okay, one thing is... This can never be blue by itself, right? It has to be the same as this region. So this is a separate region here. So these are the same region. This is the same region. We just don't know which ones it goes to, right? So if this is blue, is that helpful? Don't know. That would guarantee red is here. Red has to be one of these two, so this one would be red. Hmm. Hmm. If this is 5, okay, so if this is 5, this becomes 7, that's 9, this is 1. That's fine. That means this is not 5, this is 2. This is 5. So far that's fine. 9. This can't be 2 or 5. That means this can't be 2, so this is 4, which makes that 2, which makes this 4, which makes that 8. 4, 3, 4. This can't be 5. These can't be 4. These can't be 9. This can't be 3. Can't be 4, 8. So these would have to be separate regions here. This 7 would have to go here to a 5. This 7 would have to go here to a 5. And it'd be 5 and 2, so this could not be red. Actually, it doesn't have to. This could be the blue 7. This could not be red, though. So this would be different than this region. This actually seems okay so far. No 2. 4, 5. No 4, 5. Um, remaining digits would be 1, 3, 6, 7, 8, 9. This can't be 8. This can't be 3 or 9. So far, this is looking okay. This has to go up because it cannot be part of this. So this would go up. Oh, interesting. This cannot go this way because that would be a separate region. So this would be a separate region. This would have to be a separate region, and this has to be a separate region than both. Right? These two are obviously different regions because they both have a 5. These two are obviously separate regions because this must go out and it's a 4, and this has to go somewhere else. So this is part of this region. It has to go out here, but this region has to go this way, and this region must go this way. The problem, though, is that's 3 regions, which we don't have enough regions there. It's just yellow and pink. So that's going to be a contradiction. So this cannot be a 5 here. This has to be 1. This is 1 and 7. So this can't be 1 here. What happens if we make this still 5 and 2? And this is 4, 2, 4, 8, 4, right? These are separate region. This must be a separate region too. This could be the same. Okay, this would be 7. Ah. I guess that could still work. This can't be 4 and 8. This can't be 7. This can't be 7, so this is 9. This is 5. So that makes this 7, which means it can't be 7. That's 9. That's 7. So no 7 or 9, no 9, no 7 or 9. None of these can be 7. This can't be 2, 4, 5. It's 8 or 9 here. This can't be 4 or 5, so this is 1 or 9. If this is 9, this is 4, 5, 4, 5. If this is 1, this is 4, and that's 5. So this can never be 1 here. We have 1, 3, 6, 8, 9. This can't be 8. This can't be 9. This is pretty convoluted. Anyways, this can't be 5. This can't be 5. This 4 eliminates 4 here, so this is 3, which makes this 4. This 2 eliminates 2 here, so it's 9. No 1. No 4. No 2. No 9. 3, 5, and 8. This cannot be red. Well, no, one of these would be 5. So one of these would have to be red. So that would guarantee it's not 3 or 8. It would have to be 5. So this would have to be a 5, 8 pair. And this can't be 5 or 8. So this is 3. This can't be 3 here. This can't be 3 here. This is pretty convoluted for the geometries here. These would be different, obviously. So one of these would be red, yellow, or pink and yellow. The other one would be pink, one would be yellow. This could go this way, so it doesn't have to go this way. But it almost certainly contains that then. Red has to go out somewhere, and it needs access to a 6. This is pretty convoluted. I would not consider this just challenging. The geometries on this are pretty crazy, right? There's with the product and the sums potentially being possibilities. It's just, yeah, there's a lot of possibilities here. Um, hmm. Blue's one of these two. Seems fine. Is there a way we can get around it with like going the other way? Or is there a contradiction we can run into if we go the other path? Maybe that's the way. This seems actually like okay. So say this was 2, this was 4, that's 2. This is 5 and 7, which makes that 5. So this can't be 5 here. Oh, that's interesting. Huh. Interesting. Anyways, this 7 means this can't be 7, so this is 9, which makes this 7, which makes that 9. That makes that 7, which makes that 9. That's interesting, too. Hmm. This can't be 7 or 9. So I think this was forced to be in the same situation either way. Huh. But that's from bifurcation, right? To... So the possibilities for this cell. So if this is 2 and 5, 4, this is 7, that makes us 9. Oh, this was 9 either way. Okay. So we make this 5 and 7, that's 5. That makes this 9. Wait, no. So that's 9. This is 7. This is 9. That's 7. Okay, how did it... That's 9. Huh. Right. Yeah. Oh, this is 1. Since this is 1, this can't be 1 here. Therefore, this is a 7-9-7-9 pair. This is B. That eliminates 7 and 9 in the rest of row 2. So this can't be 7 or 9. It's a 1-3-8 triplet. If this is 2, 5, that makes this 7, which makes that 9, which makes that 5. If this is 5, 7, that makes this 5. That makes that 9. So this is 9, and that's 7. So this can never be 7 here. It's 5 or 9. Okay. Interesting. Thing is, 5, 7 is less restrictive here. That's why I don't want to go down that path. But... Okay, so this, I think this has to have a 5 in one of these, right? It's either 2 times 5, which is 10, or 5 plus 7. Yeah, so one of these is guaranteed to be a 5, which eliminates 5 in the rest of the column. So this can't be 5. I think 2 has to be one of these guaranteed also, right? If this is 5, 7, this is 2 times 6. If this is 2, 5, obviously 2 is in the column. So 2 has to be one of these two, which means this can't be 2 either. Huh. Okay. We have 7 is either A or B. So there's a guaranteed 7 in columns 5 and 6. One of these 7s in a 5-7 pair has to be a 7. That means the rest of column 5 and 6 cannot contain a 7. That's why we can eliminate 7 there. We can eliminate 7 here. This could be 1, cannot have 2, could be 3, 4, no 5 possible, could be 6, no 7, 8, or 9. And this can't be 9 because of the 9 in the row. So that's the limitations for those squares, or those cells. I would consider this hard. There's a lot of convoluted possibilities here. And I don't see an easy way to get rid of them except for bifurcating, essentially. So I don't understand why people are saying this is just challenging. Okay, again, this green region needs 4 and 8. But the 8 could be anywhere here. It cannot be green, green here. Or green, green here. But it could be green, green here. Because if it's green, green here, that's both 4 and 8. And that would eliminate all possibilities for that cell. So these can never be green. You could go green, green. No, you can't. Because that would be 4 and 8. So this can't be green either. So it could be green, green here, 4 and 8. Or this is both green and green. Or you could have 4 and 8 here. Either way, okay. That is one interesting aspect. Aha, I see it. This is actually quite difficult to spot, though. The green obviously cannot go this, this, and this because they're not consecutive. 4 and 8 are not consecutive. Red blocks this way, so it can't go down. In these green cells, you have to have a 4 and an 8. You're guaranteed a 4 in one of these 4 cells, though. In rows 5 through 7. In rows 5 and 6, you're guaranteed a 4 here. In rows 6 and 7, you're guaranteed a 4 here. That means there's a green in one of these 4 cells. There's a 4 in one of these green cells. There's a 4 in one of these 2 cells and a 4 in one of these 2 cells. That's a guaranteed 3 4s in rows 5, 6, and 7. That eliminates 4 in the rest of the cells that are in 5, 6, and 7. Therefore, this can't be 4. This is a 2, which makes this a 4, which makes this a 2. This is 2 and 6 multiplied together, so this must be 5 and 7 added together. Therefore, that's how we come to that conclusion. So these can no longer be 5. This 7 eliminates 7 here, so it's 5. This 7 eliminates 7 here, so it's 9, which makes this 7, which makes that 9, which makes that 7. This 5 eliminates 5 here, so that's a 9. 9 can no longer be here, and this can't be 9. But that was pretty complex way of getting it. This 2 eliminates 2 here and 2 here. These can't be 4 because they're not part of this 4-8 pair, this 3-4 pair, or the greens. We have a 7-9 pair in row 5, which eliminates 7 and 9 in the rest of the row. So this can't be 7, and this can't be 9 or 7 or 9. You can't have a 4, a 2, or a 7, 9 in this cell. So it's 1, 3, 5, 6, or 8. This cannot be 1 or 5, so this must be 3, which eliminates 3 from these cells. 3 can't be here. This 3 eliminates 3 here, so this is 4, which makes that 3. So 3 cannot be here either, and these can't be 4. Therefore, this can't be 2 green digits here. So green has to be one of these 2, which makes one of them a 4. Which eliminates 4 in the rest of the column. Also, one of these 3 has to be an 8. That eliminates 8 in the rest of the column, so this can't be 8 here. That makes this a 3. So this can't be 3 here. This 3 eliminates 3 here, so this is 6, which means this can't be 6, that's 3. This can't be 1 anymore. This can't be 3 anymore. So this can no longer be 2. Where is the 2 in this dark region? It has to be here, so this can't be 2 either. 5 would have to be with 4 or 6, and this can't be either. So this can't be 5 then. 8 is one of these three, so this can't be 8 here for the green. 4 has to be one of these two. Okay, red can only be, well, it doesn't have to be either of these. It could just go this way. This is 5 or 9. 4 has to be one of these two. It could be 5, 4, and 9 there. Or 5, 4, and 1. Or 9, 4, and 5. Um, 4 has to be one of these two digits here, and 4 has to be one of those two digits there. If it goes gray and gray, that doesn't work. Because this would then have to be 4, and this couldn't be 5 here. This can't be gray, because it can't... Right, so this is red or pink or yellow here. Let's see. This can't be 3 because of the 3 in the column. This can't be 6 because of the 6 in the column. What are the remaining digits, actually, for these cells? 2, 4, 5, 7, 8. Okay, so that is valid. This is a 4 or 8. What are the remaining digits here? 1, 2, no 3, 4, 5, 6, no 7. It could be 8, no 9. 4 cannot be here because we have 4 here and a 4 here guaranteed. Oh, this is not a 7. So this can't be blue. Well, the blue has to then go here. So this is all done. The red needs... Okay, this can't be red because that would block in the green. And the green has to be one of these three. At least. Actually, yeah, it has to have 2 out of these 3, so this can't be red either. Well, it could be. It could go 1, 2, 3. That's possible, actually, so that could be red. Never mind. That still could be red. It could go 1, 2, 3, 1, 2, 3. Yeah, yeah. Okay, this is pink. Interesting. So if this is pink going this way, and it's just 4, this is gray. Huh. That's interesting. So these are separate regions, but it could be red. Oh, this can't go this way. So this has to go up. So these are all the same region. So we're going to mark that as yellow, but it could still be the same as the pink. In fact, I mean, these are all unique digits. So it could just be one pink here, right? But these have to be a separate region than this. Hmm. Seems fine. Hmm. Okay, where is the 3 remaining in column 5? These are all eliminated by 3s in the row, so it must be here. So this is 3 guaranteed. Um, to work with 8, it has to sum up. It sums up to either 4 or 8 here, because actually, yeah, we have a 4-8 pair in row 5, which eliminates 4 and 8 in the rest of the row. So this can't be 8. This can't be 8. We have a 1-5-1-5 pair, which eliminates 1 and 5 in the rest of the row. So this can't be 1 or 5. So it's 6. So this can't be 6 here. Where is the 6 in row 6? It has to be here. This can't be 9. So this is 1 or 4. So this can never be the single digit. These two have to be the sum, because 4 must add with something to add up to this digit. So this digit is separate. So this can never be gray. If this is gray, this would have to be gray, but this can never be 4. And we need access to a 4. So this cannot be gray. It could be gray here or gray here. We don't know which. So this is a boundary. This has to go out somewhere, so it has to go here, and it cannot be gray. Therefore, this can't be gray. This must be gray, medium gray. And this must be then 4 and 5. So this is 4 and 5, which makes this 8. This can't be 5 or 8, so that's 4. So this is done as a region. That makes this a 9. Okay, so 9 cannot be here. This is 2. This makes that 9. This can't be 2 or 9, so that's 8, which means this can't be 2, 8 or 9, so that's 2, which makes this 9, which makes that 7. That's 2. 7 eliminates 7 here, so that's 9, which makes this 7. This can't be 5 or 7, so that's 1. This can't be 1, so it's 5, which means this can't be 5, so that's 1, which makes that 5. These can't be 2 or 5. No 2 or 5 here. This can't be 1 or 5. This can't be 5 or 8, so this is 7. This can't be 7, so it's 5, which means consecutive with 4. 3 and 4 have to add up. This can't be 4 or 8, so this is 7. These both must be green. So this is done as a region. Okay. Red needs access to a 6. This cannot be red anymore. This must be separate regions, so these cannot be red either. This can't be red because it's a 2, so these must be all red. So this is a region by itself. And these have to be the same region to add up to 4. So this is 1. This 7 eliminates 7 here, so that's 8, which makes this 4. That makes make this 8. And the regions are, this is the same region. This has to be a different region than the 9, so this is all pink, right? This yellow has to go out here, and it forms with this cell. Because this must be pink, therefore, this cannot be pink here. This must be all yellow, but this yellow has to form a region here. Right, so this cannot be pink. This is all pink. And these are the regions. Because this needed access to a 4. It couldn't match this then, so this had to match this cell. So this is an 8. This 1 eliminates 1 here, so that's 8, and that's a 1. And that's the solution. Yeah, I would not consider this just challenging. This was very convoluted how to get through here. Yeah, this was not just your typical challenging puzzle. This logic was pretty convoluted, and you had to go through a lot to actually figure this out. I would classify this as hard. Not quite very hard, because the logic was still pretty consistent throughout, but it was just, this logic here was pretty hairy. And that's more challenging than just a simple challenging puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.